Ian, we're getting some feedback from your mic. We're hearing your PC's audio instead of your mic, so if you want to just check your settings. Cool. All right. Well, while Ian sorts his thing out, let's get started. I'm gonna try and keep this to an hour, and if we get however far we get, and we can do like a part 2 next week. So I've imported our plate here. I'm gonna try and keep and so the first thing we want to do is make sure our project settings are set to the same frame range as our shot. So if you press S, in this area here, it'll pop up your project settings, and so it's set already to the correct range, which is good. And let me just check. Yeah, okay. So this is our plate, right? And of course this is the final version. So I'm not sure how well this is going to work, because this is the first time I've ever even attempted to reverse something. But I reckon we're going to get a pretty okay camera track. The biggest thing for this is to get the camera track set up, because that's something that in a film situation, like in a film studio, we wouldn't have to to do a camera track. I've just realized that the Facebook stream's probably delayed. Is it
a little bit?
Yeah, like 10 seconds.
Yeah. Can you hear me now with like?
Yeah, I can hear you now. That's good.
Better?
Yeah, way better.
Cool. That was weird. It is delayed by a couple seconds.
Do you guys want me to is it an issue? Because we can pause the thing, take like 15 minutes, and I can get it onto something that will be a lot faster.
No, it's okay, I think.
It's okay? Alright, for the next one we'll make it a bit, I'll choose a different streaming service. Okay, cool. So, first thing we want to do is add a camera tracker for our source. Now, I don't remember what any of the camera information is. If I knew like the focal length for this shot, I'd be able to plug it in here and get a better track. But we're going to choose free camera from source. All these I think we can basically leave as they are, and we'll just track. Right, so if you guys have used tracking in Nuke, it's pretty great for sort of B-grade sort of quality camera tracks. But in a visual effects studio, they're always using something like is it Mocha, or Silhouette, or something. I think 3D Equalizer. They're the main ones that'll be used, and they can get down to under like 0.1 of a pixel of variation, which is pretty damn good.
Yeah.
So cool. So we have this basic track. So we need to improve this based on see these tracks here. These are highlighting red because the systems notice that they don't conform in the same way and don't solve a camera. So it's rejected them. But we probably want to also reject like tracks like this, because this guy's head is going to be moving in the shot, so we didn't really want to use that. So in order to really, the quickest way to fix that is to create a mask. So if you press tab and you go roto, you can add a roto roto node, or you can just press O on the keyboard. And I'm just going to clear our properties bin, and with this open, I'm going to full screen our main our viewer, and I'm just going to draw a quick circle, like a quick mat around these guys. And then I'm going to go to the first frame, and this is going to create a just a really quick mat for us to use to tell the software not to look at that area. There's other ways we could do it. We could take the track quality and we can filter that, but we're probably going to have to do that later anyway. Press Z. You press Z to sort of smooth your shapes. So this is probably pretty good. And we'll go to last frame, and
what is this allowing you to do?
With, adding in a Luma key. So if we need it, we might add a Luma key later. So I'm just going to skip through these frames. Make sure that
you have to do it frame by frame.
As I play through it, we just want it to roughly cover that guy, and then we'll add another one. You click on this button here to add a new one, and we'll go around. Right, and it doesn't matter which frame you start on. Generally, you would start on the first or last frames, and then work forwards and backwards from there. But you can kind of start wherever. You just have to remember, because it adds keyframes. Even if you add just a single one of these points, it's going to add a keyframe for that frame if you add it. So just be aware that, yeah, those blue lines are the keyframes. Alright, so actually let's just check this second one. Alright, so there's an issue here as our last carriage goes off screen. We need to take this off screen to there, and we'll go forwards and just get rid of it. So now just line these up, just tweak them.
And do you have to do these for every single frame, or no?
Alright, that should do. So now if we look at the alpha of that by pressing A, we can see this animated, these animated shapes. And if we plug this little tab here, basically most nodes will have this little tag without a tag on it, without a description on it. If you drag it out to mask, like the merge node has an A, a B, but then you've got this guy. So this one has a mask here, and we're going to plug it into our roto, and then we have to tell it what we want to do with that, whether we want to include it or disclude it. So source alpha is our mask, so I can never remember which one I'm supposed to choose for this, so I just guess, and let's resolve. Oh, actually, sorry, that was source alpha, so that's actually using the alpha from this, which we could do, but I've actually plugged it in, so we can go to mask alpha, and now if we go track, yeah, there you go. So it's mask alpha takes the white area out. So at the moment you can see here that it looks like we're tracking black information, but it's actually just because we're looking at the alpha channel, and so we're just seeing the white areas. Cool. Everyone's just still working. We'll get your maybe after the stream, Art, we'll get your mic working. I can see that your mic is muted in the list, so you might want to just check in your settings under voice and audio, just check these things, make sure that they're set up correctly. Okay, cool. So now if we look at our RGB, we shouldn't have any tracks that are attached to these objects. So these are the paths. So this path comes over this, but the actual track is this X here. So now let's click on solve, and it gives us an error rate of 0.97. And what that essentially means is there's a 1 pixel error rate across the track. So we will get a 1 pixel shift, and in a film sense, that might not sound like a lot, but in a film sense, it's a huge amount, because the human eye is really attuned to picking up the tiniest little bits of variations and slippage like that. So what we can do is we can come in here, and there's a couple of different things we can do. Now I can't quite remember which one it is. I think error max and max error, right? So if we select, you can select multiple of these by holding control, and this one is one of the things we want to select, and it's the maximum error per track. So that's basically the accuracy of each one of these tracks that we have in the scene. And then if we hold control and select max error, this tells us the limit that it's going to cut off anything above that, and it's not going to use. So if we change our max error from 3.6, sorry, that's max track error, which I think is actually different. Yeah, it's max error is at 7.58. If we drag this down, we're going to it's going to start clipping into this, into our curve. And if you look on the viewer, you'll see that some of these lines are starting to turn red, and what that's saying is that those are becoming rejected tracks. So we don't want to remove too many. We want to keep as many as we can, but we want to cut off some of these peaks that you see in here. So right about there will be probably fine. There's another way of doing this, which I think is with the RMS. Yeah, so this here, excuse me, I actually have no idea what RMS means. I've never really looked at it. Average reprojection error per frame, righto. So with these two, we can bring our max track error down, and I think if we just clip off those top ones, and so now what we have to do is we go delete rejected, and anything that's red in here is going to get rejected. Delete unsolved is another one if there are some tracks that didn't actually manage to get an accurate enough point. We can delete those, and you can also add user tracks. So in here, if there's a particular point that you want to track, we can add a track and say, let's pick, because we don't have any tracks in this area, maybe we should pick one like here, and you just move it to there, and then we can go forwards a couple of frames, and we can move it. So this is one way of improving your track, is with a manual track. Personally, I've never done it. I find like when you're in a studio, you don't need it because somebody does the track for you. But at home, if I'm tracking something, it's not. I don't need it to be, the highest quality. But we can see actually there's this track here. I'm just going to delete this user track because I don't want it.
And for the track,
we can
you
see
keep
this
it on
track
the same
here
spot?
is not actually tracking properly. It's sort of wiggling around. So we can select it and delete it. And you could potentially go through and and check others. There's also other things you can do about deleting tracks with a certain length, because longer tracks are better. So I think it's track length minimum, and then is it minimum length. So we got so these two. So it's already done a pretty good job of culling all these ones that it's not going to use. Right. Just checking if there's anyone who's jumped in since we started. Just for the record, just use your mic, Ian,
Well,
so that I can
you hear me now?
just immediately hear what your questions are.
No.
Do you have to do this frame by frame? For, if I'm assuming you're talking about auto tracks.
Yeah.
I can't hear you anymore.
No?
Oh, I must have hit a button. Okay, I can hear you now.
Oh, okay.
Cool. Yeah, so are you talking about like frame by frame for this area on the right, or
Yeah.
Yeah, no, you don't. So this is across the the whole timeline. So it goes from you can see here there's 0 to 40 is the frames, and that's the length of our clip. So
Okay.
once you cull in the auto tracks, it does it for the entire clip range.
Then for putting that track on the mat, do you put them in the same little spot?
What do you mean by that?
In the frames? When you're adjusting the track?
Oh, manually?
Yeah.
Yeah, so if you want to add
in the same
a
spot.
manual track, you basically go add track, and then this is your track, and you want to pick a point, and then go frame for a user track like this. You have to go frame by frame and go back like this, and then you have to make sure that you have to go to the right spot every time.
Okay.
Which can be a bit difficult sometimes, because sometimes the camera can be all over the place, but
Right.
that's where it is, and then so like that. So the other way of doing like this is to get a 3D camera track, but if you just wanted to do a 2D track on something, like let's say we didn't have a dynamic camera like this, we just had something that was like, say at the start of this frame, that we just wanted to track something on here, you can do that just with a standard tracker node. So this one here has again, it's very similar, but if we say let's put this on this guy, and the inner box is the pattern that it's looking for. Actually, let's do it on top of this. So the inner box is the pattern it's looking for, and the outer box is the area that it's going to look for that pattern. So the bigger you get, the bigger you make this, the more chances of it like jumping around somewhere else. But if you have a really dynamic camera move, you have to make it a little bit larger. So if we position it here, and then we can go and click on this, which tracks from forwards from the front to the end, and it's going to actually track that until it sort of loses its track. So in this case, it's actually managed to hold onto it reasonably well, but you can see that like over the course of that sequence, it's not exactly a great track, right? But that's a way that, you know, if you just had a push in or a pan or something really basic, you could use just a 2D tracker if you just wanted to match something in there. But we're trying to recreate the camera.
And you're trying to recreate this for like the matte painting over.
Yeah,
right?
Yeah. So we need to know the 3D camera so that we can figure out where the ground is, and we'll be able to do that after we solve the camera. So now our camera solve has an error of 0.78. So we have a couple of options here that you can create. So the first one is just creating a camera, and this creates a camera that it tries to line it up with the ground, but it doesn't often get it right. But this shows us how our camera moves. There's a couple of other options. That's multiple views, right? Camera set. I've never looked at camera sets, but there's a scene plus. I believe this is like a mini projection setup. So it tries to give you your lens distortion. This is your point cloud from the camera, scanline renderer, the scene node, and your camera. So if we view this scene node, we can see, let's just get rid of that. So it's showing us the camera, the point cloud, and everything. So we can potentially align our objects to this point cloud. Okay, so the next thing we want to do is, I don't think we need necessarily, let's see what the distortion is like. So by pressing D on your keyboard, you can disable and enable nodes, but it doesn't seem to be doing anything on this. So usually we would have some like distortion information, but it doesn't. So we don't need this setup. Man, I wish we could stream with two screens. That would be so handy, especially with Nuke. So we have a camera and we have our plate, and now we don't need these nodes anymore, but we'll just leave them there. So the next thing we need to do is create a ground plane for this for the plate, so that we can start projecting on top of it. And cool, no one knew. So what we can do is we have a point cloud generator. So this requires a camera to be built before and tracked, and the better your camera, the better your point cloud is going to be. And so we're also going to use our roto mask, which so that we don't create a point cloud for these horses and things because they're moving. So it only works with static objects, that at least this, you can't have two moving objects where you have a camera and a moving object. You have to have either one or the other. So okay, so in our mask we want to say again mask alpha, and we'll just click on analyze sequence. And what this does is it goes through the sequence and it tries to find keyframes to add that it can use to recreate a point cloud. Now in this instance it's created a whole bunch of keyframes, which is really good. You can also we could delete these and we could just choose a manual keyframe spacing, and just it'll just do it every 15 or 5 or whatever. Unfortunately that says nan, which means it's probably failed to calculate something. But if we go just continue on, see if it'll work. So what this is going to do is going to create a much more dense point cloud than the camera tracker. So the camera tracker uses only the most accurate points to create a camera track. The point cloud generator will actually try and create a full point cloud for the entire, basically the entire area. So we'll give this a minute. It might take a couple of minutes. You guys got any questions? I'm looking at the live streams as well, so if you have any questions there, just yell out. If you guys are on the live stream, you should jump on the Discord server. I put a invite, and you don't have to sign up for Discord. You can just join it, so you don't have to have an account, which is pretty handy.
Yeah. So far so good, I think.
Yeah. So what we can do, actually, I think while this is going, maybe we can. So if we previously, when we looked at this, it's frozen. When we looked at our 3D view, we could see that the points in the geometry were not aligned to the real world, the ground plane in Nuke. So we can use an axis node and just anchor everything off that axis node and rotate it back. There may be other ways to do it that are better, but I'll just show you what I was talking about so that you can get what I mean. Yeah, so if I turn the grid on in here, you can see that our camera is sort of looking weird. We know that our camera is meant to be looking down at this ground, and we can see that our point cloud is sort of going out into the sky, which it'll be way more obvious when we now come back to our point cloud generator and we look at this. So this is our entire sort of plate reprojected in as many places as it can, and you can see here there's a remnant of our mask in here where it's not been able to fill in the points. So I might just for clarity, we'll go put our point separation to 1, and oh sorry, no, we'd have to retract that, so don't worry about that. We can change our point size though and decrease the point size. But in our point cloud, so what we're going to do is use the point cloud to create a mesh from the point cloud, and we want to reject any points like these ones out here. It's already selected some that are red, because if you tick this box, it displays the ones that are rejected. So with these two sliders, you can reject any points that are either beyond a certain density threshold or beyond a certain angle threshold. So I think what it had to start with was pretty good. Just 1, and we might just color a little bit more because we're really only interested in the ground, and for that matter we don't, because the ground is flat, we don't really need geo. We really just need to know where is the ground in relation to the camera. So I'm going to click delete rejected points, and this is what we're left with. So I probably want to get rid of these points out here as well. So let's just see if we can. Hang on, those ones are from our previous point cloud. Cool. So the next thing we want to do is we come to, and I think it's vertex selection, and we can select our points. So that was this little drop down here. We go to vertex selection, select them, go create group. So now we have a grouped point cloud, and we can select that, and we can go bake selected groups or bake selected groups to mesh, and this will create, or at least attempt to create, a mesh for us. Assuming it doesn't crash.
Does Nuke crash quite often?
Not really. Not in a. It may be because I'm just working on a tiny little laptop that struggles. In a studio, I've found most of the time it doesn't. It'll usually be when you're doing something a little bit outside of the like the normal usage. If you're just doing sort of tracking and projecting and that, it'll never crash. Alright, so if we change our selection back to node, we can see here we've got a pretty good mesh based on that area. Right, so it's still rotated up, which doesn't really matter, but just for the sake of it, I'll show you guys how to change that.
And this mesh allows for the matte painting to be on it without it parallaxing weirdly.
Yeah, it should do. I mean, it's not going to create. It's not made the bushes that you see in the shot. So there were some bushes out here, and there was. It has somewhat created the curb along the edge of the road. You can kind of see that this is the road, but it's missed out on creating all the little bushes. Like, let's go back. Like, these ones. So. You might see some parallax if you were trying to like project something fancy in that area, and similarly it hasn't created any mesh up here. It's sort of just only around here, but we'll find out in a minute. Actually, what we can do is if we create a scanline render node, plug our camera in and our object and our background. And if we change select this guy and change his settings from rendered to, let's go, maybe not wireframe. Yeah, let's do wireframe. Right, so we can see here this is what mesh it's created. So it kind of has included these horses, unfortunately, so we might have to go and recreate it, but it's created a mesh for this. And if we play this through, we can see, I think like these little mounds here are not so much of an issue, because we can just replace this ground because it's so flat. We can replace it with a card and just a ground plane that will do the job for us. And so if I zoom in on say this point here, if we've got a good track, we should not see it move at all from, we should see this little patch of the plate remain exactly where it is throughout the shot. So it slides around a bit, but it's not too bad. Actually, I'll show you guys a trick. If you want to check your track, you can, if you add a tracker, and we can just let's add it to, actually we'll go to the first frame, we'll add a track, and we'll just position it, say we want to check this area, and go like this, and let's track to the end. So this should track pretty well because it's tracking like, really high contrast information. So, alright, that'll do. And if you come into your transform tab of your tracker and change the transform to stabilize, what that's going to do is it's going to center the screen around this point, or center this point to your screen. So now, if we full screen that, it should do, but it doesn't seem to have. I might need to.
So does like the director tell the studio like what kind of lens they use and like the diameter of the film, or is it pretty standard, like what that ratio is?
It changes a lot. So yeah, you have they have I can't remember what they're called, but it's basically a shot sheet for each shot, and you have just all the lens and camera data for that particular shot, and you can you often find that they'll use an Alexa camera for one sequence, and they'll use a red for something else, or like they'll use completely different cameras. And I've even seen like digital cameras and then film cameras used all in the same show. So they sort of choose. I think what happens is because the Reds have a certain quality to them, and the Alexas have like a warmer feeling. So I feel like the director probably chooses a camera based on how they want the shot to look in the end. So I don't feel like it's I don't feel like it's like a consistent thing at all, really. So yeah, and the other thing that's really super annoying for match move artists is that the camera data is half the time it's not even correct. Like it can have just sometimes they just mix things up, and sometimes the guys on set they don't use the data, they're just taking the data, and they probably a lot of them don't even know what it's used for. So they just don't really necessarily care. So what we're going to do is I'm going to flatten out this our geo. So we're going to look. I added a transform geo, and I plugged the axis into this axis, and the only reason I did that is because this way I can use this and I can plug it into other things like our camera. I can plug it into, and you can transform entire scenes. Whereas if I used a transform geo node, then I'd have to either copy the transform geo to the other nodes as well. So by making the adjustment in here, I can use it again and again. So to rotate, you hold control. Move is by standard. This is the move tool, and control is for rotating, and then I think it's control shift for scaling. In software like PhotoScan, you can tell it which points you want to align to your as your ground plane. I think there might be something like that in Nuke, but honestly, this is sort of stuff that you'll do more of this work when you're freelancing, or if you're just doing your own stuff. This is super helpful, but in a studio sense, it's all done for you. Cool. So I've got my axis node. We've transformed our geo, but now our camera needs to be transformed as well. So I'm just going to copy the camera, and we'll plug in transform geo again to, just this. So the camera's input, the only input that it has is for axis transforms. So it's been moved now to its location. Just see if there's anyone else who's joined. Nope. Cool. So now we have our geo, our camera, and we can try doing like a test projection. So I'm just going to clean this up. So at the moment we have our camera tracker that we got our camera from, and then we generated a point cloud from the camera, and we don't need this anymore. And then from that point cloud we generated our baked mesh, and we're transforming that to flatten it out. and that's just via the axis. And then we want to project onto our baked mesh. So the standard setup for a projection is basically this. I think I showed you guys on the last thing, but so you set your frame for your projection, and you frame hold your camera, because this is an animated camera, so we don't want to, if we don't frame hold it, then the camera is going to move as when we're projecting. We don't want to do that. So we want, so just as a side note, the sort of setup that I'd normally go with looks like this. Let's go. Just gonna load anything in here, like this. So this will be our DMP in here. So this is our Photoshop file essentially in the end. Then this is our projection setup and our camera, and we're projecting. We've chosen frame 1, so this would be basically frame 1 of our shot, and we're projecting it through the camera onto the geo, and then rendering out the geo through the camera again. But because we have this transform geo node, the other way to do it is you project onto the geo after this. So we plug and apply material in, and I'll just move these around so that they flow in the right direction. So we have our camera, and we're applying the material to our geo. Does that make sense?
It kind of does. I would go over it again.
Yeah. So it's just, the only reason we're doing this is because doing it this way is because we are transforming the geo from its original location. So if we went and projected this into here, what we're doing now is projecting the camera from its new location onto the geo at its old location, and it's not going to look right. If we look through here, see how there's this issue here. So we're projecting from our camera at the new location, which should be projecting onto this geo down here, but because we've got this transform geo after our projection, this geo is getting projected on, and then we're moving it, which is not going to have the right result. Nathan's asked, I think you can align the track. Oh, he said you can align the track to the ground by picking the points in the ground. Oh, okay, yeah, right. I just haven't even looked. I think in the camera tracker. Oh, maybe it's in here. I remember being able to do it at some point, but I just haven't needed to do it, so you just forget these things. Maybe it's this one. Let's just have a quick look and see if we can. There we go. So this is how, yeah, thanks Nathan. So we could select like a bunch of these and go, yeah, like set them to X, I guess is what we'd want. And that would then rotate everything to the ground plane. But I'm not going to do that because I've already generated the mesh. So Okay, so this is our projection setup now. I'm gonna just delete this, clean this up again. Alright, so in order to test our projection, I'm gonna add a checkerboard, and we have to just make sure that the checkerboard has the right format, as the same format as our input. So it's 1080, so it's HD. Alright, so now we're projecting our checkerboard through frame 1 onto our geo, and then applying the material. Sorry, I need to unplug that. And applying material and rendering it out. So it might be a bit clearer if we do this. Okay, so let's have a look at what it looks like. Okay, we need to change our geo to textured. Alright, so this is our geo, and that doesn't look quite what I would expect. Oh, because we're not at, if we go to frame 1. Okay, cool. So if we then play through this, you can see, and actually it'll probably make more sense if we let's grab our plate, and down here we'll just copy it, and I'm going to merge our render over the plate, and I'm just going to set the mix to, like, you know, super low, so that way we can just see the two and see if there's any slippage or see if there's any issues. Alright, cool. Let's just buffer this. Alright, so we've got like 15 minutes left. I think we've gotten pretty far. We've gotten to a pretty good position. Now there's like heaps of slipping there, I'm not sure why. See that there? So this is telling me, like, this movement here is tracking our horses, which it shouldn't be. Let's just try, let's go back to, let's get rid of our axis and this, and we'll just do a standard sort of projection. And so, you know, our world is rotated slightly, but that's okay. So let's see if there was something wrong with that projection, maybe. No, apparently this camera is moving strangely. Let's have a look. So if we go through these, it seems right. And our point cloud. Frame 1 onto a geo. These things always prop up when you least expect them. Some of the most simple stuff, and you just I might pause it soon. If I can't just figure this out really quick, I'll pause it, figure it out, and we can continue in part 2. But let's, have you guys got any like general questions about Nuke, or any questions from this like that I haven't answered. Gotta buy a beast of a computer. Yeah, you're right. I used to have a really beastie machine, but then I had to up and move overseas. I didn't want to take it. Right, let's go wireframe. So I'm just going back a step to check our baked mesh, and we'll check that on render as wireframe, and we'll look at it through our and check exactly why. See if it's slipping here. So if it's not slipping here, it shouldn't be slipping in the projection, and it's not. So I believe this might be this. I reckon this is a formatting issue. Alright, let's check this. Alright, see this. Alright, awesome. I reckon that fixed it. Yep, it has. So the reason that happened was that, and this is something I should have also set up right at the start to stop this sort of thing from happening. Our input plate resolution is 1920 by 1080, but our project settings, again, you press S while in the node graph, and you want to check and make sure that this is set to the same resolution as your plate. So what the reason that was an issue is because the scanline renderer here will render your image at whatever resolution your project settings is set to. So that's why it was rendering it at I can't remember anymore. I've changed it, but it was over 1080p, which meant that when we merged it over our plate, it wasn't the same resolution. So it was overlaying it as like a 1-to-1 resolution to the plate, so it wasn't aligned. To fix that, just then I plugged in if you plug a BG pipe into here, it will take the format from whatever is being passed to it. So that's one way of fixing it, but the better way is to actually just fix your project settings. So now we have an image that is sticking to our ground plane. So let's just wait for that to buffer again. So this button up here with the lines on it, that forces full frame processing. So what it means is that if I zoom out to here and I'm at 71% zoom, Nuke only renders the lines of pixels that you see on the screen. So without this turned on, I wouldn't be able to wait until it buffers like this and then zoom in and zoom out without it. Like it would then want to update its renders. So now you can see, like here, these points are all sticking, which is awesome. There is a little bit of slippage, but it's like super close. Like you can see here on this little part here, if I scroll back and forwards, you see how it just slides underneath this white checkerboard. So that's not ideal, but it'll do. Okay, so from here, the next step that we would do is we want to save this out because we want to repaint onto it. I'm not going to create a ground plane in replace of the geo because it's pretty much covering everything I need, and it's sticking. But if we wanted to, we could come in here, create a card, and we could go in and like scale this up and position it and just align it so that we could have a card in here instead. But this works way better. So to project, to do our work on the first frame projection, let's go with like a frame hold, and we'll set this frame hold to. Actually, we don't need that anymore. So we'll set this frame hold to frame 1 because that's the projection frame that we want. But we probably also want to do it on the last frame as well, because you're probably going to want a couple of projections, particularly since this last frame is practically none of it is seen at the start. There's a little bit through here, but if we paint on this, if we paint lines on this, by the end of it they're going to look stretched and warped, so you got to start blending projections. But just for the setup, we'll go frame 1 and we'll go frame 39, which is our last frame, and let's bring them down here. And what we're going to do is we're going to add a switch node. So a switch node, and this is just, you don't have to do this, but it just keeps things a little bit more clean. So we will plug the switch node into our first frame hold, and we want to choose the frames that we want to use for this switch. So actually I think we need this above the switch, maybe. We'll find out in a second. So the switch node allows us to plug it into our plate, so that we have we want our plate at frame 1. If we view this, it's our plate at frame 1. We also want to get our checkerboard at frame 1, so we can plug our switch into the render as well. And then if we change our switch to frame 1, we can see our checkerboard. Now it's not entirely useful actually, because it's just a flat checkerboard, but you may do like a top-down projection, so create another camera, or just say, instead of projecting this checkerboard, we could, if we copy and paste this and we just apply the checkerboard, we may have to, this probably won't work because we don't have UVs on this. Yeah, so it doesn't work. But if you had a UV'd object, you could project onto that a checkerboard, so you get a little bit more information. So I'm going to change this this geo to render as a wireframe. So when we switch the switch to 1, it's going to give us our wireframe, and when we switch it to 0, it's going to give us our plate. And often, like I'll do this for if you've got EXRs with multi-channel things like normals and indirect, direct light, ambient occlusion, position pass, like whatever you want. You can plug these all into a switch node. Then we want to frame hold it on frame 1, and then the trick comes in when you go to write it. So we press W to add a write node, and we'll choose all channels, and we'll just select a location, and we'll call this output, and you want to put the hash or the pound symbols after, and that's a like a hot symbol for Nuke to replace that with frame numbers. And then we want to go EXR or TIFF for this case, because we're going to take it to Photoshop and TIFF works better. We'll go 16-bit, and the rest of it is fine. We want to check our frame range, and we want to limit this frame range, because we only want two 2 frames. We don't want the whole sequence, because we just want the 2 frames that we're rendering. So we change this to frame range 1 and 1 to 2, and if we write this, it's going to render the 2 frames to our folder. And if I add a read node and I go to this location, it's got our output here, and if we view it, we can see we've got our plate. But if I go to our first and second frame, you can see that this is changing, but there's no difference in our viewer, and that's because we haven't actually set our switch to change. So the trick here is, if we right click on this little box, instead of manually changing it, we can set a keyframe. So we go to the first frame, go set key, and it sets it to 0, and go to the second frame and change this to 1, and now our switch will switch between the 2. Right, so it's going to, like, if we view this, you can see this highlighted pipe. So this so Nuke always tells you where it's reading information from based on the highlighted pipes that it's showing. So if we switch between our 2 frames, it's going to show us that it's reading from the plate, and then it's reading from our setup. So now we have an animated switch. If we render out this write node again, and we've already got our files read in, we just have to click the reload button, and then if we go to our second frame, we should see famous last words again. It hasn't switched, it hasn't worked out. It may be because of this frame hold, so we may have to just copy this into here. I believe that's the issue. And now if we render this out, and if we reload this and we go to our second frame, tell me it's there we go. So now we've got the 2 layers that we need in Photoshop that we're concerned with, and we can start repainting. Now this is not necessarily very handy in this instance, because we have a plate. Often you won't, though. You'll just have CG render, or you'll just literally just have geo and you have to paint over, in which case a wireframe is really helpful. So we take this into Photoshop, do our paint overs, and then we bring it back in and we project it. I am going to save all these files for you guys, so you can pick over my my setup, and that's about it. I mean, we can do another session next week on bringing it back in, but it's pretty much there at this point. It's just a matter of bringing it into Photoshop, doing the artistic side, and bringing back the alpha'd areas and creating more like a compositing job from now on, because we have our technical setup and we know what we have to do in a matte painting sense. So yeah, do you guys have any last questions? I'm looking at the chats now, so I don't think there's any other questions, so that'll be it. If you guys liked it, just let me know. We can do more of them. I got a ton of stuff that I've worked on that I've got real shots for that we can pick apart and redo. Yeah, but if that's it, then thanks for joining, guys. And just so you know, the Discord channel is up from now on, so you guys are welcome to jump in there, chat. I would say use the Facebook Academy group more often than not, but if you particularly if I'm available and you want to have a quick chat because you've got an issue with some particular technique, I'm happy to join, to just jump in and have a look and have a chat. Sweet guys, thanks.